class now. Okay, now we finished the yes or no. We finished the yes or no situation. We move on to the mean, to the number, to the number. Um, well, we are in class now, it's recording. So the formula is different from the proportion. It's similar, but z, the critical value is the same story. It's the same story. The standard deviation, this part is different. This part is different. Is the S is the sample standard deviation and divided by the square root of a sample size divided by the square root of a sample size. Let's look at one example and okay, let's look at one example. So this is for some kind of high school math national exam. High school students, senior, the last year high school students, and they take the national exam. They take the national exam. And we want to find out the national average. We want to find out the national average. But, we cannot add every student in the country and divide it by the total number of students. So they did a sample. In this year, they selected the 2,204 students who took the exam. And the mean, the symbol, notice there's a bar, okay? This means the sample average. This means the sample average. The national average, what's a symbol for national average? What's a symbol for national average? What's the symbol for national average? This is for national average. Mu. Okay. This is the sample average. This is the sample average. Okay. The average that is for 2,000 students. They get this. And these are 2,000 students. They get this. We want to know this. We want to know national. We want to know the range. We cannot get the exact number. But from here, we can get this range. Have a feeling that the U.S. students, how they are doing. Okay? And over there. I cannot show. Let me copy down the formula here. Um, let me copy down. Just said what for the question 21.9. Originally 21.7, question 21.7, the margin of error is 0.03. 21.9 asking if I want the margin of error be smaller, half of this. Then what is the n? In here, the n is 1,012 people. If I want this to be smaller, the sample size, what's the sample size? Many students do a lot of calculation. Actually, to make this half, it means this needs times 4. Because 1 dividing is 1/2. Do you see it? This is original. This is original, which gives out 0.03. If you have times 4, then you have this. Because this take out the square root is 1/2. Is 1/2. So for this question, we need 4,048 people. It's 4 times larger. The sample is 4 times larger. If you want this to be shrink, your sample needs 4 times larger. Okay. This is a 21.9. Sometimes sometimes 1,000 is already a large sample. If sometimes the sample is small, the margin of error, if n is small, the margin of error is large. Margin of error is large. Then if you did a study and your margin of error is 42% plus minus 30%. Wow, this is crazy. Could be anything. Right? Then it becomes 12% to 72%. Then you say the national proportion is 12% to 32%. That is very large. This is why we need, we prefer, if it's possible, we prefer the n to be large. We prefer the n to be large. When the sample is large, the margin of error is small. Okay. If you want it to be half, you want it to decrease half, you need 4 times the sample. So for this, you don't need to do a lot of calculation. It's just 4,048. proportion. This is a proportion formula. This is a proportion formula. And I write down for the mean, it's in white. I'm out of the color. This is the formula. This is the formula for the mean. The S is the standard deviation of the sample. Standard deviation of the sample. S is the standard deviation associated with the sample. If it is the whole population, then it's sigma. Sigma is the standard deviation for the whole population. What's this? What's this? What's the meaning? Meaning. Yeah. It's a population mean. Population mean. Like in this question, the national average is a mu. Anyway, they want the 95% confidence. And now this time they are showing off. They are using 1.96. If you use 2, it's okay. If you use 2, it's okay. Okay? So basically they plug in the formula 1.96 and the standard deviation is 33.7 divided by the square root of the sample. And so in the end is 1. Okay. So what's the meaning? What's the meaning of this? It means the national average is between 150.2 to 153. Okay. It means the national average, 95% confidence is in this range. Yeah. So if you randomly selected a high school senior student, let's say you select 100 high school senior students. 95 of them, their score is in this range. 5 will be better than this or worse than this is outside. Okay? If you randomly selected 100 students, 95 of them in this range, and some may be even better, some may be even worse. So, when you go to, you guys are young and healthy, and but later when you go to hospital, and they want you to do the blood test, and after you take you get the report, and the doctor say let's say your red blood cell is too low. Your red blood cell is too high. One, they will give you a range on the report. The normal people range is from here to here. That means normally they use 95%. Means the majority people, 95% people, 95% healthy people is in this range. Some kind of medical number is in this range. If your number is above this range or is lower than this range, there are two possibilities. Listen. One is you are sick. Another possibility is you are still healthy. Because this is 95% people. 95% healthy people range. Get me excited? You're too healthy? 95% healthy people in this range does not mean the 100% people in healthy people. There are still 5% healthy people is outside this range. You could be that 5% healthy people outside this range. Or you could be, you are just sick. So in older medical, let's say blood pressure. So what's the normal blood pressure? What's the normal blood pressure? So there's a range, right? Normal blood pressure, there's a range. And that range, how do they get that range? They get a sample, a healthy people sample. They get a healthy people sample. Let's say they get the 2,000 people. And these people are healthy. And their blood, the average is 151.6. Standard deviation is this. Then after you calculate it, you get this range. So you say the 95% of time, you calculate this, then you project, say, all the healthy people, 95% of them should be in this range. Otherwise, how do you know the normal range? You have to measure every human being on the earth, and the healthy, the blood pressure, and say, okay. So you got to say 95% healthy people is in this range. Okay? This is in the medical, I cannot show you my medical report. It's too healthy, I don't want to show you. In every medical report, they give you your number, and they give you the normal range. And that normal range is 95% of the situation. Okay? Your number and the is the blood pressure. Here is your white blood cell. Here is your red blood cell. So on so. pH, whatever. Are you following? So when you see your aunt the medical report, you aunt say, oh, mine is outside of the normal range. You say, yeah, you maybe you are just that 5% outstanding people. Or maybe you are sick, you are really sick. Okay, I think I stop here, and I will be back.